So going back here, just on the graph itself, if I wanted to find the unit rate, I would look for here in 1 month, and this point right here, 61, or sorry, 160 is my unit rate, right? Which tells me if I were to write that as a fraction, it's $60 in 1 month. So I can use the graph to help me find my unit rate. Another way of finding a unit rate would be to use what you've been using, k equals y over x. Obviously, the money is the y, and the x is the number of months. So it'd be 60 over 1, and your k would be 60, and ta-da! It would become from there. Knowing that k equals 60, you can write the unit rate. So what's the constant proportionality? We already did that, and that is 60. So, and it doesn't matter what point you would take. So let me take another point just over here. This point would be 0.5 right here, 0.5 and 30. So the point 0.5 and 30, let's see if I get the same thing. So if I did, it's my x value, it's my y value, so I did k equals x over y, I would get, y over x, x being 30 and y being 0.5, and if I divide 30 divided by 0.5, I would get 60. So again, you can see that the k, the constant proportionality is the same. Okay, so it doesn't matter what point you use, what coordinate point you use, you will get the same constant proportionality. But when it's already given to you very easily, 1 and 60, there's not much I need to do. So just by looking at the graph, I know that the constant proportionality is 60. Moving on, so let's see, number 2, what is the best, which quantity is the input and which quantity is the output? Well, the input is the month, and the output is the, the money. So the total amount of money, so the money, use the sentence, the money depends on the months. All right, so this makes this my dependent and this my independent. So this is my dependent and independent. Remember, dependent is my y, my total, my result, and independent is my x. And that's how I know. Okay. Make a table by predicting. So again, you can use a table, and you had 0, and this would have been in 1 month it was what, 60? Was it 60? No, 1 month was 60. Yes, it was 60. 2 months was 120. 3 months would have been 180, and 4 months would be 240. And now remember when we did this in class, and you did k equals y over x for any of these points. So for 0.4 and 240. For 0.3 and 180, right? If you did y over x for each of them, they would all give you 60 as the constant of proportionality. Okay. Write an equation. So your equation will always be, if it's proportional, will be in this format: y equals kx. So let's substitute our k with the value that we found, and we found that k was 60. So y equals 60x. And what does my equation say? My equation is saying that if I wanted to find out the total amount of money, raised, I would just multiply 60, right? Y represents my total, so I would multiply 60 times the number of months, and that's what my equation is saying. Okay, let's move on here. I don't want to make it too small. Where are we? Okay, here. No, we already did that. So this one is writing an equation from the given table. Okay, so now this table, and apparently, okay, so we're using a table. So I'm going to write the equation. So if I want to write the equation, I need k, yeah? And k is also known as my unit rate. Can you see which of these values is my unit rate? Well, my unit rate is the one where x equals 1, which is this one right here, right? So k in this case is 6. So if you were to do k equals yx, you would get 6 divided by 1, which is 6. If you took this point and you did k equals y over x again, you would do 12 divided by 2 and you get k equals 6. Third one, 18 divided by 3, you would get k equals 6, and so forth. So it doesn't matter which one you took, all of them would give you that k equals 6. And if k equals 6, the unit rate, sorry, the equation would be ky equals 6 times x. Okay, so you can also look at the table and you can see that, listen, how did the 5 become a 30? Times 6, times 6, times 6, times 6, times 6, etc. Okay, so your equation equals y equals 6x. 4, what is the unit rate for each pound of chicken? So 1 pound of chicken is, so now the problem here, this is it. The graph is in cents, so this is not $100, 100 cents. So I'm going to just change this to $1, $2, $3, $4. Okay, I don't know why they did it in cents. I don't know what they get out of it. $5, and the last one is $6. So what is the unit rate for 1 pound of chicken? So this is the pound. So 1 pound of chicken meets here. And halfway between 0 and $1 is 50 cents. So my unit rate, according to the graph, is 50 cents for 1 pound of chicken. And I used my graph to find it. Okay. Explain the unit rate in words. It's 50 cents for 1 pound. Create the table. So if we create a table, we can write pounds, 1, 2, 3, 4, 5, 6 pounds, and we can find the cost for 1 pound is 0.5. 50 cents, $2. 2 pounds would be $1. 3 pounds would be 150, 2, 250, and 3. And that's how my my table would be done. Okay. Equation. So what's the equation? Oops, sorry. So here's my equation. Remember, we have to put the equation in this format. We define what k is. Well, let's find k a different way. So let me pick this point here, 4 and 200. No, which is 4 and 2. Sorry, $2. So 4 and 2. And if I were to do k equals yx, I would get that y is 2, x is 4, and that's going to give me 0.5. So my constant of proportionality is 0.5. So using that, I can just plug it in here. Y equals 0.5 times x. What does that represent in word? It represents in word that y, which represents the cost. The cost is equal to 50 cents times x, which is the number of pounds. Okay. How does the equation relate to the graph above? So the equation and the graph show a proportional relationship, right? A, because the graph starts at 0, 0, right? It goes to the origin, straight line, and it's proportional. Cindy's Bakeries loves to make cupcakes. The table below shows the amount of icing per cupcake. So icing per cupcake. So this is, I'm just going to put an X here. This is going to be my Y, right? So this is, write the equation that represents the amount of icing per cupcake. Now, I want to look at the unit rate. The unit rate is what happens when there is 1. In this case, 1 cupcake. So they use 3.5 ounces of icing. So if I were to write this as a fraction, 3.5 ounces of icing for 1 cupcake. And there's my unit rate, right? So if that's my unit rate, what's K? K, obviously, is this guy right here, right? 3.5. So if I were to write my equation, it'd be Y equals 3.5 X. Yeah. So 1 cupcake, I use 3.5. 2 cupcakes, it'd be 2 times 3.5, which obviously you can see here is 7. 3 cupcakes would be 3 times 3.5, which is 10.5, and so forth. So I can use the equation, this equation, to find out. Okay. Check your answer by plugging two values for C and two values for I to see if it forms equal expressions. So here's my equation. Y equals 3.5x. So what they're asking you to do is literally pick any of these pairs. 4 and 14, 3 or 10.5, 2 and 7. Pick one of those, put it in here, see if it works. Let's pick this one, 4 and 14. So 4 and 14 is written this way. This is my x value, this is my y value. Let's plug it in here, see if it's true. So y is 14, and 3.5 times 4 should equal 14 as well. Does it? It does. So you can see that the equation works. You can plug, put another one. So let's pick another one that doesn't deal with decimals. So 2 and 7. Would 2 and 7 work in this equation? So y equals 3.5x. I'm going to substitute the y with 7, substitute the x with 2, and I get that they are equal, because 3.5 times 2 is 7. Number 6. Here is an equation. Again, same thing. They're asking you to use a table and find the unit price. Now, look at the good thing about this one is that they didn't give you what one apple costs. So the unit rate is not given to you right away. So you actually have to do some calculation. So here's my x, here's my y. So to find a unit rate, let's use k, right? So it would be k equals y over x. In this case, y is, I want you to pick any of these, 8 and 20, 6 and 15, 4 and 10, 2 and 5. Pick any of those and find them. So let's just pick this one, 8, 20. So k equals y over x, so k equals, here's my y, here's my x, it'd be 20 over 8. And k equals, and 20 divided by 8, yeah, I've calculated that. 20 divided by 8 is 2.5, so k is 2.5, which makes the unit rate 2.5 over 1, and let's put some units, $2.5 for one apple. So that's my unit rate. So I have my k, I have my unit rate. Unit rate's $2.50 for one apple. What's my equation? Well, my equation is going to come in this format. Y equals kx. And we need to find out what k was, and we did, which is 2.5. So y equals 2.5x. It makes sense. It's $2.5 for every apple that we buy. So it's y equals 2.5 times x. What is your equation saying? Well, exactly what I said. Y, which represents the total price, is equal to $2.5 times the number of apples I will buy. So use your equation to determine the total price if you purchase 30 apples. Well, so here's y equals 2.5x. So if I buy 30 apples, I'm going to change that to 30, multiply by 2.5 to get my total y. So y would be 2.5 times 30, which is going to give us $75. And I used my equation to find. So the answer is 75. 7. Let me bring this a little bit higher. You ran a marathon, create a table. Okay, so now we're asked to create a table. Right? We're going to create a table. So my x and y, so this is my x obviously, and this is my y. Uh-oh, I made this wrong, so let's change this. Oh, hopefully you guys, this is hours. This should be miles, so that graph is incorrect. So let's create a table. So this would be hours. This would be miles, which is my y. This is my x. So in 1 hour, can we tell how much he went? He went 5 miles. There's my dot right there. In 2 hours, he went 10. 3 hours, 15. 4 hours, 20, and so on and so on. So can we find a constant proportionality? Well, pick any of these values. 1 and 5, 2 and 10, 3 and 15, 4 and 20, and then plug it in here. I'm going to pick this one, right? Listen, it's obvious. Everybody knows that it's 5, so I'm just using something else just to show you that when you don't have that showing, you can use other values. So if you did 15 over 3, you would get 5, and the constant proportionality is 5. And you can clearly tell 5 divided by 1 is 5, 10 divided by 2 is 5, 15 divided by 3 is 5, so forth. So it didn't matter which one you showed, but you didn't have to do any work because it's also given to you right here, or even in the graph. Okay, so what's the equation? Well, you know that k equals 5, so the equation is going to be y equals blank over blanks times x, or k times x, and we know what k is. So in this case, k is 5. So this is my equation, y equals 5 times x. Is it reasonable? Let's substitute and see if it does make sense. Okay, so I have 3 and 15, I got 4 and 20, I got 5 and 25. So I have several points that I can use. So let me pick a point. Let me pick a point that I already put in my table, 420. Let me pick the point 420 on this graph, put it in the equation, see if it makes it true. So this is my x, this is my y. So let's substitute. So I get 20 equals 5 times 4. And obviously that is correct. So my equation is definitely the right equation. Okay. One more. Ugh, so that one. Okay, so yeah, I'll do it. So what is it? What's going on here? It's supposed to have been your exit ticket, but I guess not. So it says can be purple. The table below shows the amount of red paint to amount of blue paint. Okay, so we need red paint to blue paint. Let's make this x. Let's make this y. Okay, so if I did k equals y over x, I mean, obviously, already right here, if you look right over here, you can already see that the k is going to be 4, but it's because I want to make it, I want to use this. So let's use the point 4 and 16. And if we divide k equals y, which is 16 divided by 4, I'm going to get that k equals 4. So our constant proportionality is 4, right? So which means my equation, I'm just going to fill it in, is y equals kx, or y equals 4x. Okay? And then fill in the blanks, you're going to need 1 cup of red paint for every 4 cups of blue paint. Yeah? That's what my thing is saying. Check with 2 order pairs. You can just check. Let's take, again, point 4 and 16. Substitute. So you get y is 16, right? So substitute here. Change the x for 4. And you can tell that it works. Okay. This one, I didn't like this one only because the graph is a little weird. I don't know why they make the graph like this. So I'm going to make a line here. I'll just leave it. But it starts at the origin 0, 0. I don't like this, the way they did this graph, so that line should be shifted over a little bit. Okay, so write an equation that can be used for the price C. So we're buying blueberries, right? So 1 pound of blueberries is what? Well, if I create a table, okay, so pounds and cost. Obviously, this is my x and this is my y. So if I buy 1 pound of blueberry, I can't really tell how much it is. I'm going to leave that blank. But if I buy 2 pounds of blueberry, it's going to cost me 5. 3 I can't tell, but 4 I can. 4 pounds of blueberry is going to give me 10. So let me use 2 and 5. So the point 2 and 5, which is right here. K equals y over x, which would be 5 over 2, and k equals 2.5, which, if I turn that into a unit rate, it's going to be 2.5 over 1, or 2.5 dollars for 1 pound. So that makes sense, right? $2.5 for 1 pound. So my equation, so I forgot what the first question is. What's the question? What's the constant of proportionality? The constant of proportionality is 2.5. So my equation is going to be y equals 2.5. Okay, for every so x, for every pound that you pay $2.5. Okay. How does the equation relate to the graph that is shown below? Well, you can tell that for every 2.5, we there we go. We pay 2.5 pounds. We pay, no, for every dollar, every pound that we buy, we pay 2.5. So you can see here, 1 pound is 2.5, $2 would be 5, and again, every pound increases by $2.5. Okay, that's that. I think there was something else. Pause.